Welcome back, AP Chemistry students. We're now at section 1.7 on periodic trends, part 2. So in the last video, we finished up talking about the trends for ionization energy and atomic size or atomic radii. And now we're going to talk about the trends for electron affinity and electronegativity, which I described before as being sort of two sides to the same phenomenon. So the electron affinity is the energy associated with electrons being gained. So this is like the opposite of ionization energy, because in ionization energy you had electrons or energy being absorbed to remove electrons. Here we have electrons being gained and energy being released. And electronegativity is basically a descriptor of just how likely this is to happen in the first place. So the more electronegative, the more electron affinity there is. Though the trends for electron affinity are pretty inconsistent and hard to predict, so we're going to likely tie them to the trends for electronegativity since they're kind of two aspects of the same thing. So electronegativity is mostly based on size. So if we consider this diagram below, I have this electron here that is placed equidistant between the electron clouds of two atoms, one being much bigger than the other. And we want to figure out what's going to happen to this electron. If it's sort of equally between these two spaces, where is it going to be attracted to? Well, I already have kind of a spoiler on the figure. It's going to be attracted to the smaller one. And the reason for that is if you actually measure the distance from this electron to the nucleus, this distance is actually shorter than this distance due to the smaller radius of the atom, which means there's going to be a stronger Coulombic force. Because if you remember in Coulomb's law, the strength of the force is relative to the distance between them. And the smaller the distance, the more you feel that force. So that means that we can sort of map the electronegativity trends to the trends for the size. As the size increases, the electronegativity is going to go down. As the size decreases, the electronegativity is going to increase. And you can see here on the periodic, this version of the periodic table that has values associated with the electronegativity, we could see that the most electronegative elements, represented by the orange, are here in the top right corner, which corresponds to the smaller atoms on the periodic table. And the lowest ones, corresponding to this blue color, are here in the bottom left, because we are increasing in size as we go from top to bottom, and we are decreasing in size as we go from left to right. So the trend for electronegativity is also going to be sort of a arrow pointing towards the top right of the periodic table. And we're just going to assume that the electron affinity trend is going to kind of be the same as the electronegativity trend. So an overall summary of all of these trends, the atomic radius is going to decrease as we go from left to right, and that was due to the increasing pull of the nucleus, the increasing effective nuclear charge as the amount of electron shells stay the same. And our atomic radius is going to increase as we go top to bottom, because for each time we go to a new period, we're adding a new shell of electrons, and it's gonna the valence electrons are going to get further and further out from the nucleus, increasing the size of the cloud. For the ionization energy, it's going to increase as we go from left to right because the effective nuclear charge is increasing. Much like when we were talking about the atomic radius, the amount of shielding electrons, the amount of electrons that are pushing the valence electrons away are staying the same in a row, but the amount of protons in the nucleus are increasing, and therefore the pull on those electrons is increasing. And the ionization energy is going to decrease as we go down the periodic table, pretty similar to the explanation for the size, but each time we go to a new period, we get a new shell, those electrons get further and further away, and then based off of Coulomb's law, we know that as the distance increases, the force decreases. Electronegativity and electron affinity are going to increase as we go from left to right due to the size shrinking down, and the distance from the nucleus to some electron near the atom is going to increase, is going to decrease, increasing that Coulombic force of attraction as that distance gets shorter and shorter as the atom gets smaller and smaller. And then sort of by the same reasoning, the electronegativity and the electron affinity are going to decrease as you go down, because as you get a new shell, each time you go down to another row, you're going to increase the size of the atom and make any electrons sort of hovering near the atom that might get attracted towards it farther and farther away from the center as you go down. So these are overall the periodic trends of the table. Please make sure that you can not just memorize these trends, but kind of understand the reasoning why and how the reasoning is related through Coulomb's law. And I'll see you in the next video.